Hi everyone. So this is me Pooja, Assistant Professor of Department of Information and Technology, SNS College of Technology. So welcome you back to another video on the topic data types. Uh, in the session, we'll explore data types in Java. Data types are the foundation of every program we write. Without a clear understanding of this, it's impossible to write efficient and bug-free code. By the end of this video, you'll understand the different types of data in Java, how they are stored, and why choosing the right data type can make a huge difference in the memory usage and performance. So, Java is known as a strongly typed programming language. This means that every variable we create must have a declared type, like int, float, or string. Why is it important? Because it makes our code safe, reliable, and predictable. Think of it in this way. Like I'm saying, I'm giving you 10 apples. You know exactly what to expect from it. But if I just say I'm giving you 10, you're left confused, right? 10 what? What does that mean? The type removes the ambiguity. In programming, understanding the data type helps us use the memory efficiently, improve the performance, and prevent errors caused by mixing up the different kinds of values. So there are two types. One is primitive data type and the other one is non-primitive data types. So in primitive data types, there are a lot of varieties. So these are the basic building blocks. So starting from byte, short, int, long. So byte, it is a tiny 8-bit signed integer ranging from like minus 128 to 127 positive. It's useful when you want to save some memory, especially in the large arrays. And short, it is a 16-bit signed integer, which ranges from about minus 32 768 to 32767. An integer, the most commonly used one, 32-bit signed integer, and it ranges from about minus 2 billion to positive 2 billion. And the long integer, it is like the 64-bit signed integer capable of storing really huge numbers in the range of quintillions. Now let's talk about the decimal numbers. Like for decimal numbers, we are going in for float and double. Like float is a 32-bit floating point type, good for saving memory when you need the decimal values but don't need the high precision. And double, a 64-bit floating point type with much bigger or higher precision, up to 15 decimal digits. This is the go-to type for any scientific class calculations. So, the thumb rule is that use the smaller data types when memory is critical, but use the larger ones when the accuracy is most important. So let's move on to the non-primitive data types. Like beyond the basics, Java also has these non-primitive data types. These are more advanced and are created from the classes. Like these are strings, arrays, enums, classes, and interfaces. Like when it comes to a string, these represents a sequence of characters like words, sentences. For example, it can be like mechanical consisting of MECH within the quotations. And then it when it comes to arrays, these are like containers that hold multiple values of the same type. For instance, as if the array of integers could store a mark of 100 students, wherein the marks of 100 students is a value and not a character. And then comes the enums. These define a set of constants like days of the week, Monday, Tuesday, Wednesday, and so on. So these kind of constants are being stored in enums. And then when it comes to classes, a class itself by itself is a user defined type that can encapsulate both the datas and those methods and its methods actually. When it comes to the interfaces, these allow the classes to implement these multiple behaviors, serving a contract that enforces consistency. So while primitive data types are like atoms and non-primitive data types are like molecules, the bigger, the more powerful and capable of modeling complex real-world entities. Uh, Then when we go into the next thing, we are seeing like typecasting. So sometimes we need something to convert one type of data into another type of data, and this is called as typecasting. So there are probably two types of casting, and one is the implicit casting and the explicit casting. Like in implicit casting, it is also called as the widening conversion. This happens automatically when a smaller type is converted into a bigger type, like assigning an int into a double, like we said before. So there's no risk of data loss here. But when it comes to explicit casting, it is also called as narrowing conversion. Here, we manually convert the larger types into the smaller ones, for example, a double into an int. This can lead to a data loss because the decimal points may get cut off since these are bigger numbers which is being converted into the smaller numbers. For example, when we are taking a program where we have declared a variable with a value of 10, and double y is equal to x and double z is equal to 9.78, and then the integer a is equal to int of z, casting makes programs flexible. But we need to be very careful with the explicit conversions. And then when it comes to the wrapper classes, the Java is an object-oriented language, as we said before, and sometimes we need to treat these primitive types as objectives. That's where these wrapper classes comes in. For example, we are representing this int like int into integer, integer, and double into the capital double, and char into the character. So this particularly useful in collections like array lists, which only works with objects and not primitives types. And these wrappers, they help to bridge the gap between the simple data and the object world of the Java. And then it comes to the type promotions. So another important concept is this type promotion. When we use mixed data types in an expression, Java automatically promotes the smaller types to the to match the larger types. Like the int of a is equal to 5 and double of b is equal to 6.2, and the result is a plus b. Here the int a is being promoted to a double automatically, so the calculation is accurate and consistent. This promotion ensures we don't lose the data unexpectedly. And then also so before coming into the let's understand the type safety in datas actually. When it comes to the type safety in data, uh, it is one of the strongest feature of Java actually. So first one is that compile time checking. Here the Java checks the type mismatches before running the program, preventing those runtime errors. And then comes the final variables. Once these have been assigned, their values cannot change. This prevents those accidental modifications. And then comes the generics. So these allow us to write flexible codes while still enforcing the type safety. For example, let's say array list and then a string. It ensures only the strings can be added, avoiding the runtime errors. And then comes the static type checking. So here this helps detect the type related issues earlier, saving time in debugging the later. So type safety is the reason Java programs are more reliable compared to the loosely typed languages. So as a conclusion, to wrap up, mastering the data types in Java is not optional actually. It is an essential part. Choosing the right type improves the memory efficiency, the performances, and prevents the bugs. We have seen the primitive types of basic data and non-primitive types of more advanced modeling, like typecasting for conversions, wrapper classes for object handling, and type safety for reliability. In short, if you want to become a strong Java programmer, understanding the Java types is one of the most and very first steps you should actually take serious. Um, so thanks for watching the video, and if this breaks down the types of data type, it's actually good. So let's see in the next following video. Thank you.